welcome back. This is going to be a lesson over section 11-2 for statistics. If you remember in 11.1, we learned two inference procedures. The first of which was the two-sample t-test. And if you remember, one of the assumptions of, necessary to run a two-sample t-test was that the two samples were independently chosen from the respective populations, or that if you had a group of volunteers or a single group of randomly selected people, that those people were randomly assigned to treatments. Okay, either way, it can result in it being appropriate to run a two-sample t-test. Now, what we're going to learn today, and this may be two videos, I don't know, but the first inference procedure we're going to learn about is something called a paired t-test. Okay, and I have a data set on the whiteboard right here, and we're just going to talk about what this means first of all. So there were 10 movie critics that were randomly selected from among the population of critics in the United States. And they were asked to watch and rate two movies, one of which was Superman from I think 1978, and one of which was Avengers from I have no idea when, but much more recently. And the critics were instructed to watch each movie, and give each movie a score out of 5. They could go to 2 decimal places if they wanted to. And what we want to know here is, which movie did critics rate better, and do we have sufficient evidence to say that one movie was more higher rated than the other movie?
Of course, you're gonna choose Superman. He loves Superman.
Let's look at the data set here first. Critic number 1, for example, gave Superman a 3.55 rating and the Avengers a 2.95 rating.
Told you.
Critic 2, however, liked the Avengers a bit better than Superman, as you can see, and on down the line. Now, here's the thing, okay? We have a data set here and a data set here, so perhaps we could compare these using the two-sample t-test that we learned in section 11.1. Okay, and I did that. If we wanted to do that, of course, and I'm not going to write out the whole test, I'm just going to show you what happens here. Well, I'd have to find the mean of this data set, which is, let's see, 3.011. That's the mean. Okay, that's X bar sub S. Okay, the average rating for Superman. And X bar sub A for the Avengers movie is 2.558. Now, it's probably not surprising to most of you that Superman had a higher average rating than the Avengers, which has very little heart and soul.
Oh, be quiet.
Anyway. However, is that just due to random chance? Based on the set of critics that we randomly selected, or would this provide sufficient evidence to conclude that Superman is a higher rated movie than Avengers among the population of critics in the United States?
Maybe
well,
critics.
If I run a two-sample t-test here, and I have the standard deviations written down here as well. Let's see, S sub S is 0.882, and the standard deviation of this data set, if you're following along at home, is that's S sub A 0.550. Okay, the sample size is n from each one of these samples. And if I run the two-sample t-test, what I get is this. I get t equals 1.378, which gives a p-value of 0.09 4. Okay, and that's for a 2-sample t-test where the null hypothesis is that the difference between the mean rating for Superman and the mean rating for the Avengers is 0, and the alternative hypothesis is that the mean rating for Superman is greater than the mean rating for the Avengers.
Oh, be quiet.
But if you look at the conclusion here, with a p-value of 0.094, of course our conclusion at any reasonable alpha level would have to be that we would fail to reject the null hypothesis. We did not find sufficient evidence running the 2-sample t-test to conclude that Superman is a higher rated movie among critics than the Avengers is. However, the way I just did this is dead wrong. Here's why. The 2-sample t-test cannot be used here because these were not independently chosen random samples. Okay, this was the same set of 10 critics that each one of them rated each of the 2 movies. This data point here, the 3.55, is naturally paired with this data point right here because those 2 ratings came from the same critic. So since these were not independently chosen random samples, there is no way that I should run the 2-sample t-test like I just did. And what I should do instead is what I'm about to do right now. Okay, we're going to introduce a new procedure. As I said before, this is going to be called the paired t-test. Okay, now this data set is about to go away, so if you want to take a screenshot of it or something, you can. But, I already have it typed into a calculator and such. Maybe you should too. Oh, by the way, calculators. If you did not swipe one of our yellow calculators at school, okay, I want you to know that there's a free option. TI is making software available for the TI-84 platform on any computer, okay, because of this whole pandemic. And so if you go to TI's website, you'll be able to figure out how to download that software onto a computer so that your computer can run something that's just like a TI-84. Okay, now I'm going to erase this, and we are going to do a 2-sample, or sorry, not a 2-sample t-test. We're going to do a paired t-test. A paired t-test is appropriate when the samples are not independently chosen, but that rather they're paired naturally somehow. Now, when can that occur? Okay, or when does that usually occur? One of the most common places where that would occur would be a before and after situation. For example, if you got a group of 30 people, you selected 30 people at random, for example, and you measured their weight before an exercise program, and then measured their weight again after an exercise program. Okay, the data would naturally be paired because for each subject, each one of the 30 subjects, you'd have a before weight and an after weight, and that before weight and after weight would form a natural pair. That's by far the most common situation. If you were doing an experiment on twins, okay, and you gave you randomly assigned one twin to one treatment and the other twin to the other treatment, that would also result in a data set resulting in natural pairs. Anyway, let's do this. So the name of this procedure is going to be the paired t-test. Teddy, how are we doing on time here?
9 minutes, 27 seconds.
Okay, I tell you what. I'm going to turn this off, the video, and in part 2, I'll run this test. So I'm going to be using the same data set. So be sure you watch part 1 first. Okay, I guess if you heard me say that, you already did watch part 1 first. Okay, Teddy, go ahead and shut it off.
Okay, Avengers is better.